Now let's learn how to relate the power of 10 to common logarithm. Relating powers of 10. Powers of 10 to common logarithm. To common logarithm. How do you relate powers of 10 to common logarithm? We should first note that a common logarithm is essentially the power to which 10 must be raised to get a specific number. That's a common logarithm. So a common logarithm, something let's call it log base 10. Log base 10. A common logarithm is log base 10. So log base 10 is just asking us how many times do we need to multiply 10 to get a number, or simply how many zeros follows after 1. Yeah, you can say that how many zeros follows after 1. Let's say let's look at this. 10 raised to 1. In 10 raised to 1, 10 raised to 1 is 10. 10 raised to 1 is 10. And when we are asked what about log 10 or logarithm of 10, when asked about the logarithm of 10, what I'm trying to ask you is how many times do you need to multiply this 10? Yeah, how many times do you need to multiply this 10 to get that 10? Yeah, how many times do you need to multiply 10 to get 10? Of course, the answer is 1. That will be 10 times 1 will give you 10. Let's look for another example. 10 squared. 10 squared is 100. When I ask you about log 100, the logarithm of 100, I'm asking you how many times will I need to multiply 10 to get 100? How many times will I need to multiply 10 to get 100? And the answer is 2 here. The answer is 2. If you multiply 10 2 times, you'll get 100. That is what logarithm is asking. How many times do I need to multiply 10 to get a number? Let's look for another example. 10 squared equals 1000. When I ask about logarithm of 1000, I'm asking you how many times do you need to multiply 10 to get 1000? How many times do you need to multiply 10 to get 1000? And for 1000 is 0. Yeah, 10 cubed. How many times do you have to multiply 10 to get this 1000? And the answer is 3. And let's look at 10 raised to 0. 10 raised to 0 is 1. 10 raised to 0 is 1. And if I ask you, what's the logarithm of 1 or log 1? I'm asking you, how many times do you need to multiply 10 to get 1? Like how many times? Like what do you need to raise that 10 to get 1? Yeah. And you'll find that log 1 is 0. Because if you raise 10 by 0, you get 1. I don't know if it's making sense. Like it's like another example, 0.1. 0.1 is the same as 1 over 10. Same as 1 over 10. And 1 over 10 is the same as 10 raised to negative 1. And if I ask you uh, logarithm of 10 raised to negative 1, like the logarithm of 0.1 base 10, what is the logarithm of 0.1 base 10? I'm still asking you, how many times will you have to multiply 10 to get that um, get 1? So what we have here is negative 1. What we have here is negative 1. Mathematically, we can conclude that logarithm is just asking us about the index. Like we found that logarithm of 10 raised to 1 is 1. Logarithm of 10 raised to 1 is 1. Logarithm of 100 is 2. Because this 100 is the same as 10 squared. So logarithm of 100 is 2. Logarithm of 10 cubed is 3. Logarithm of 10 raised to 0 is 0. Logarithm of 10 raised to negative 1 is negative 1. So we can say that when we have a number 10x, equals to y, when our 10x equals to y, the logarithm of y base 10, the logarithm of y base 10 will be x. The logarithm of y base 10 will be x. So we can say that logarithm is just the opposite of an index. Logarithm is just an opposite of an index. Like 10 raised to x is y. Logarithm of y is x. Yeah. So we can conclude that logarithm is just an index. Yeah. Logarithm is just asking for an index. Logarithm is just asking for an index. So if you have logarithm of 10, if you have a logarithm of 10 cube, the answer is the index. The index says 3, the answer will be 3. If you have logarithm of 10 raised to negative 3, the answer will be negative 3. Logarithm is just asking for the index. I don't know the easiest way to explain this. I don't know the easiest way to explain it. But can you think of it like the index or the power or the exponent is the boss in the index world. But in the logarithm world, that power becomes the answer, or that exponent becomes the answer. So, in short, I want you to know that a common logarithm is essentially the index to which 10 must be raised to get a specific number. So anytime you meet logarithm, just ask yourself, how many times do I need to multiply 10 to get this number? Yeah. Now, how upendi maths, you can ask yourself, how many zeros follow this? How many zeros follow this? How many zeros follow this? Yeah. How many times do I have to multiply 10? Yeah. Like here, 10 squared. How many times do I have to multiply 10 to get 100? How many times do I have to multiply 10 to get 100? And then you get 2. But if you don't like maths, come up in the maths, you can just count the 0, 1, 2, and then write 2. You can just count the zeros if you don't like maths. Logarithm of 1,000. How many times can I multiply 1,000? Sorry, how many times can I multiply 10 to get 1,000? How many times can I multiply 10 to get 1,000? So logarithm of 1,000 is 3. Or we just count the zeros, 1, 2, 3. Logarithm of 1,000 is 3. Let's look at a sample question to test our understanding on logarithm and how we can relate powers of 10 to common logarithms. Now, if someone asks you what's the value of log, number one, if someone asks you what's the value of log 10, log 10 raised to 7 base of 10 raised to 7 the base of 10. In fact, we don't really need to write that 10 when you're writing the common logarithm, but let's just write it for more understanding. So this one, we have said that logarithm is just asking for the index. The logarithm is just asking for the index. So in this case, it's so straightforward. This one, the answer should be 7. Because logarithm is just asking us the number of times we should multiply 10 to get a number. The number of times we should multiply 10 to get a number. So this is the same as a logarithm of this is something with 7 zeros. 7 zeros. This is like 10 million. That's like logarithm of 10 million. Logarithm of 10 million will be, you'll just count these zeros. 1, 2, 3, 4, 5, 6, 7. Then we say that the logarithm of that 10 million, the logarithm of that 10 million will be 7. I don't know if it makes sense. Let's look for another one, for an example. This is if someone asks you to find the common logarithm of the number. Someone asks you to find the common logarithm of this one. Yeah, the common logarithm of this one. What will you do? What will you do? First, First, you'll need to express the number as a power of 10 using the index law. Express this number as a power of 10. Like this one, the one as a power of 10, it is 10 raised to 3. But 1 over 10 raised to 3 is same as 10 raised to negative 3. That's the negative index law. The negative index law is the same as 10 raised to negative 3. Now, what we have here is logarithm of 10 raised to negative 3. And as we said, logarithm is just asking for the index. Logarithm is just asking for the index. The index is always the answer. Yeah? When you meet a common logarithm, the index is always the answer. The logarithm is always asking for the index. Or you can say that the logarithm is asking you the number of times. The number of times you need to multiply that 10. Yeah? Or a common logarithm is just asking you the number that you need to raise to get the number that you need to use to raise 10 to get a specific number. Or let me say that the common logarithm is asking you how many times do I multiply 10 to get this number? How many times do I multiply 10 to get this number? Or you can say that it's asking you how many zeros follow the 1. How many zeros follow the 1? So in this case, the answer is negative 3. The answer is negative 3 because the big idea here, the main concept here is how many times do I multiply 10 to get this number? Yeah, like here, the logarithm just asks you how many times do you need to multiply 10 to get this number? Here, how many times do you need to multiply 10 to get this number here? And it's so easy when you transform it into an index form. The answer will always be the index.